Okay, so now I'm going to show you how to use scientific notation with some calculations. Perform the operations, write the answer in scientific notation. So on A here, you have this number, it's a small number, right? Times another large number. Okay, but it's all multiplication. So what I'm going to do is I'm going to take the 8.14 and I'm going to multiply that times 6.5. And then I'm going to think about 10 to the negative 7 times 10 to the 10th. Okay, now the 10s, those are easy because the bases are the same, so you add the exponents. That's 10 cubed, right? So now I'm going to get a calculator for that. What's 8.14? 8.14 times 6.5. 52.91. I'm going to put a times here, but that's not scientific notation. Okay, so I did the calculation, the 52.91. You can check it on your calculator. I did the powers of 10. That was fine. But it's not in scientific notation because 52 is not between 1 and 10. So probably the easiest way to do it is think of it as 5.291 times 10 to the, I moved it one place, right? So think of that part, the 52.91, as 5.291 times 10 to the first times 10 cubed. Now use your associative property and you can combine those. So I get 5.291 times 10 to the fourth, and that's in scientific notation. So that one should be good. All right, now let's look at B. B is division. Okay, so I'm going to right away change it to a division problem. Now, this part, I'm going to do that on a calculator. And on a calculator, I'm typing in 4 divided by 1.52. I know it's going to be negative, but let me just do that. 4 divided by 1.52. And it's negative. Oh, there's a lot of digits there. Did they not tell me to round to 2 digits? I thought they did before, but it's going to be negative 2.63. I'm just going to go 2 digits. And then what would you get here for the powers of 10? Times 10 to the negative fourth. Now, is that in scientific notation? Yeah, that is in scientific notation, so we're okay there. And I rounded it off to 2 decimal places, but let me check on that. So they didn't say to round this off to 2 decimal places, but let's just say if you get a decimal that goes on and on, just round it off to 2 decimal places, I guess. The first one, that one worked out to 3 decimal places. Remember, though, this would be then considered an approximation, but it's fine. All right. Now, what have we got here? Another multiplication one. So again, I'm going to want to take the 2.7 times 6.04, and then I'm going to want to think of the 10 to the 5th times the 10 to the 13th. Okay, that'll be the fun part. All right, let me get my calculator. 2.7 times 6.04, and I'm getting 16.308 times 10 to the 18th, right? 5 and 13. Okay, but that's not in scientific notation, so I've got to move it one more place, right? If you want to think of it that way, you could, but it might be easier to just think 1.6308 times 10 to the first times 10 to the 18th, and then think of it as 1.6308 times 10 to the 19th. That's the tricky part, is you do the multiplication and then you can't leave it that way because it's not between 1 and 10. So you have to move the decimal like one more place over. So normally you would be moving it 18, if you wanted to write that big number out, you'd be going 18 places this way. But now we need to go 19 places because we moved it over one. I hope that makes sense. Okay. Last one, 1.2 times 10 to the 8th, but its division, 9.6 times 10 to the 5th. Okay, so what's 1.2 divided by 9.6? It's 0.125. And then times 10 to the 3rd power. That part, 8 minus 5, that's fine. But you can't have 0.125 because that's not between 1 and 10. So think of just this part. Think of it as 1.25 times 10 to the negative 1. Right? Because you're moving it to the right one place. So it's like a small number and you just made it get bigger because you made it 1.25. Okay, now you can add those exponents and you're going to get 1.25 times 10 squared. Now they said to leave it in scientific notation, so I would leave it that way.